Good afternoon, everyone, and welcome back to the Agentic Webinar Series. We're on episode 4 now, so if you've been following along, you know things keep getting more interesting with each session. But before we dive in, let's just do a quick recap on episode 3. So last time we got into intelligent document processing, how it's moved well beyond basic OCR into something far more powerful, and how that shift is unlocking real tangible business value. We talked about accounts payable as a prime example of how organizations are starting to move away from manual error-prone document handling and into smarter end-to-end automated processes for better efficiency, stronger accuracy, better compliance, and the ability to actually scale. But here's the thread that connects last episode to today. As businesses become more digital, more automated, and more data-driven, yes, the opportunities do grow, but so do the risks. And right now, one of the most pressing risks organizations are dealing with is fraud. Not the obvious, easy to catch kind, but fraud that is coordinated, sophisticated, and increasingly designed to slip through the cracks of traditional detection methods. So today we're shifting gears slightly. We're going to unpack what fraud actually looks like in this new landscape, why so many organizations are struggling to keep pace, and why the shift in thinking from treating fraud as isolated incidents to understanding it as connected behaviors is changing everything about how it gets detected. It's a conversation I think you're really going to find valuable. So without further ado, Carl, please take it away.
Good morning, everyone, and welcome back to the Agentic Webinar Series. This is episode 4, and today we'll be tackling something that's becoming very real very quickly: fraud detection, in a world that's becoming more driven by AI. Now, before we get into the technology, I was reading an article earlier this week about the rise of digital crime in South Africa. And it's not small numbers anymore. We're talking about organized, scaled, almost industrial fraud across banking and insurance. So I thought instead of jumping straight into the slides, let's talk about what's really happening on the ground. And to help us unpack that, I'm joined by Archie, fraud product manager here at FIRtech, and someone who spent most of his time thinking about catching people who are actively trying not to be caught. Archie, welcome.
Thanks, Kyle. And yes, that's unfortunately, a very accurate description of my job. And you're right. What we are seeing now isn't just more fraud. It's more organized, it's coordinated, it's patient, and increasingly it's using the same kind of tools and technologies that a normal bank or insurer, they're trying to use. Instead of being triggered by individual events, fraud is now identified and managed at a system level.
That's interesting because I think most people think about fraud as a single bad claim or like a suspicious transaction. But what you're describing sounds more like a network problem than a transaction problem.
Exactly. And that's where most traditional fraud detection starts to break, right? Because most systems are still designed, to look at things, one event at a time, a single claim, single payment, one customer. But fraudsters nowadays, they don't operate like that anymore. They operate across, multiple identities, multiple policies, multiple channels, and, often over a long, period of time. So if your system is only looking at isolated events, you're going to be a step behind.
All right. So if the problem has shifted from individual events to coordinated patterns, then I assume the way we detect fraud needs to change as well. Because you can't solve a network problem with a checklist.
Exactly. And that's really what we are going to unpack today. What we've been building and what we'll show later is, a system that doesn't just look at, single red flags in isolation. It builds sort of a digital footprint of, your customers, claims, policies, and the overall behaviors that are related, to each of them. And And then, we use that to surface, patterns that under normal circumstances, a human or traditional rule engines wouldn't, realistically see. And so instead of asking, is the claim suspicious? We are asking, how does this claim fit into everything else that we know? And, that's a very different way of, thinking about fraud.
All right. So if we had to make this practical, when we say fraud is evolving, that could mean a lot of things. If I'm sitting in a bank or insurance business today, what does fraud actually look like in 2026? What are people really dealing with?
Yeah. And that is where it's important to strip away the hype, right? Because at face value, a lot of fraud still looks the same. It's a claim coming in, an invoice attached, a bank account to pay, nothing obviously wrong. And that's actually the point. The individual event is often, designed in such a way that it should, mimic a legitimate claim.
All right. But if you had to give me an example, let's start with insurance.
All right. Take a fairly, typical insurance scenario. You get a motor claim, accident is reported, the repair code is submitted, everything, checks out. Now, if you look at that claim in isolation, there's usually nothing, that seems fraudulent. But immediately when we start to look at, things in a broader perspective, like things start to change. For example, the same repairer you might find is appearing across multiple unrelated claims. The bank account, that is being paid into has been used in previous claims under different names. The claimant has had multiple claims across different insurers over time. The timing patterns, individually, each of those things, if you were to question someone, they would be explainable. But immediately when you start to put them together, then you start to see a pattern.
Okay. So the fraud isn't necessarily in the claim itself. It's how that claim is connected to everything else.
Exactly. And the problem is most systems don't connect those dots effectively. So what happens is each claim gets assessed on its own. Maybe a few rules get triggered here and there, and unless something is blatantly wrong, it passes through. Meanwhile, the actual fraud, is happening in the background.
All right. What about banking? Is that the same kind of story?
Yeah, very similar, just different flavor. Take something like loan origination or account abuse. You might have a customer applying for credit, documents that look perfectly valid, income that checks out on paper. But when you start to broaden your scope of things, you start to see things like identity being synthetic, or partially fabricated. The same device or contact details are being reused across multiple applications. Again, each individual step, looks reasonable. It's the orchestration of all these things that start to flag fraud.
Okay. So whether it's banking or insurance, we're basically looking at multiple events that spread over time across different entities. That only makes sense when you look at them together.
Exactly. Fraud today is more organized, it's distributed, it's well coordinated, and often, intentionally made, to be low signal at an individual level. Which means if your detection approach is look at one thing, decide yes or no, Yeah, then you are going to miss the bigger picture.
All right. So we've got a situation where fraud is connected, coordinated, and spread over multiple events. But most organizations already have fraud systems. They've got rules, they've got case management, and some even have machine learning. But what's actually going wrong? Why are these systems not keeping up?
Yeah, so because most of those systems were designed, for a different version of the problem. They were mainly built for simple, easy to detect fraud. And unfortunately, the world has moved on.
Okay, if we had to break that down, what specifically is breaking?
Okay, first things first. Uh, first, the first one will be the walls. These walls that exist between, the different departments or the different people that are looking at the cases. We might refer to them as silos. Most fraud detection still happens in pockets. Claim teams look at claims, payment teams look at payments. Each of these teams, they focus on their own, specific work, using their own specific tools, their own rules, their own view of the world. But fraud doesn't respect those boundaries. So, the signal is fragmented across systems, and, no one is really seeing the full picture.
Okay, so even if the teams are doing a decent job, the organization as a whole is still blind.
Correct. And, everyone sees a picture, but no one sees the problem. And secondly, one of the biggest problems we have is the rules. Rules don't age well. They are a great example of, things that needs to be refined over time. If, for example, a claim is within 30 days, for example, you flag it. If the amount is above a threshold, a specific threshold, you review it. But fraud evolves and it adapts. So what happens is rules get added over time, and then exceptions get layered in, and eventually you end up with this very complex system that is very brittle. It catches what it knows, but it doesn't really perform well on anything else that is new.
Okay, and I assume that leads to a lot of noise as well.
Massive amount of noise, because to be safe, you always make sure that the rules become more and more sensitive. So now, as a result of that, too many cases get flagged, analysts get, overwhelmed, and you in many a times the truly interesting cases, uh, they get buried in this rubble, and it's a classic, signal to noise problem. And thirdly, this is probably the biggest one, the lack of context. So most decisions are made at a single point in time. So, a claim comes in, a decision is made, a transaction happens, decision is made. Today, fraud is not found in isolated events. It's a sequence of behaviors. So without history, relationship, and that behavior over time, you effectively judging a story, from reading a single page.
Okay, so that it explains why something could look perfectly fine until you zoom out.
Exactly, and and then the most you know typical one that we see, it's humans who now end up becoming safety nets. And then, because the system it's not confident, everything gets escalated, just send it for review, let the analyst decide. But analysts are limited, in time. They are limited to context and usually working off whatever the system surfaces. So you end up with a very skilled person spending most of their time reviewing, fairly low signals.
Okay, so if we had to summarize, we've got fragmented views, rule sets that can't keep up, decisions that are made without context, and humans drowning in alerts. And somehow we expected to stop organized, coordinated fraud.
Yeah. And, when you say it like that, it sounds a bit more optimistic.
Okay, so so clearly the problem isn't that we need better models. It sounds like we need to rethink how the entire system works. If you were designing that properly, all right. So clearly the problem isn't that we need better models. It sounds like we need to rethink how the entire system works. If you were redesigning it properly today, how would you approach fraud detection differently?
So most probably I will start by changing one fundamental assumption, right? If you look at most systems, they ask, is the event suspicious? But that's the wrong way of looking at it. A more better question to ask is, how does this event relate to everything else that we know?
Okay, can you unpack that a bit?
Yeah, so instead of treating each event in isolation, you start building context around it. Let's take the same insurance example that we spoke about earlier. So instead of just assessing this claim, this amount, this policy, you start asking, who else is connected to this claim? Has the repairer appeared elsewhere before? Has this bank account been used before? Are there timing patterns across, multiple claims? Now, you're not just evaluating a single claim anymore. If you look at it properly, you're more like evaluating a pattern of behaviors.
So it's less like a checklist and it's more like building a picture over time.
Correct. And, once you do that, two things start to emerge. Firstly, things that look normal under normal circumstances, when you look at them in isolation, they start to stand out. And secondly, you start to detect fraud earlier before it becomes obvious.
Okay, and where do red flags fit into this? Because most organizations already have some form of red flag logic.
Yeah. And red flags are actually still very useful. The difference is how you use them. Traditionally, if we were to look at how they were used, red flags were mostly used as, they used to be the ones that are triggering whatever that comes in. And they are the ones that inform the evaluation and then often treated as yes or no decision. But that's quite limiting. And if you look at it properly, it's quite backwards. What we found works better is treating red flags as signals, not decisions.
What do you mean by that?
So instead of asking, did this trigger a red flag, yes or no, you start asking, how many signals are present? How strong are they? How do they combine? For example, 1 week signal might mean nothing. 5 week signals across different dimensions. A strong signal combined with certain behaviors matters even more. So it becomes less binary and, more about building a risk picture.
Okay, so now we've got events, signals, and relationships between entities. At what point does this become more structured? Because it sounds like a complicated web.
Yeah. And that's exactly where you need to start structuring it properly. Because once you are linking customers, policies, claims, bank accounts, devices, service providers, you're effectively building a model of an ecosystem you're operating in. Not just a list of transactions, but a living representation of how things are connected.
So almost like a digital version of your fraud landscape.
Exactly. And some people call it a digital twin. But at its core, it's just a structured way of representing relationships and tracking how behavior evolves over time. And once you have that, you are no longer reacting to events. You are merely just observing behavior.
That makes sense because behavior is much harder to fake than a single document or transaction.
Correct. You can fake a document, you can manipulate a transaction, but it's very difficult to fake consistent patterns of behavior over time, especially across multiple entities.
All right, so we've moved from isolated events to signals to patterns to a structured view of relationships over time. That is a big shift. So let's make it more concrete. How does this actually come together in a real system? And what does something like this look like in practice?
Okay, so at its core, Skynet is built around two things, right? A red flag engine, a digital twin of the fraud landscape. And the key idea is those two don't operate, in isolation. They continuously inform each other.
Okay, if we have to break that down, let's start with the red flags because I know that's something most people are more familiar with.
Right. So, like we said earlier, red flags are not new. What's different in Skynet is how they are structured and how they are used. So instead of hard-coded binary rules, we define red flags as signals across different dimensions. Policy behavior, claim behavior, financial patterns, entity relationships, timing and sequencing. Each signal contributes to an overall risk picture. So rather than flag or don't flag, we are continuously building a risk profile as events come in.
So the system is effectively accumulating evidence over time and it's not making snap decisions.
Exactly. And that's important because fraud rarely reveals itself in one step. It emerges over a series of small signals.
All right. And where does the digital twin fit into all of this?
Yeah. So the digital twin is what allows those signals to actually mean something because it connects everything. So in Skynet, we model relationships between customers, policies, claims, bank accounts, service providers, and we check how these relationships evolve over time. So when a new event comes in, say a claim or a loan application, we don't just assess that event, we place it into that network.
Okay, so the red flags tell you that something is unusual, but the digital twin will tell you why it matters.
Exactly. One without the other is limited. Signals without context, it's just noise. Context without signals, nothing stands out. But when you put the two together, you start to see the pattern very quickly.
All right, so if you had to walk me through a simple example, what actually happens when something comes into the system?
Okay. So let's take an insurance claim, as an example. If an event comes in, what happens is we just go through the business rules. For example, checking if the claim form was submitted, verifying the documents if they are aligned to the business rules, and then signals are evaluated from there, using red flags obviously. the timing of the claim, the history of the policy, claim value versus expected norms, and any known red flag gets triggered. Now, the digital twin is updated and queried. So the output from the red flags informs now what happens inside the digital twin. Inside the digital twin, we start evaluating things like, has the repairer appeared before? Is the bank account linked elsewhere? Are there, indirect relationships, to previous suspicious cases? And then through that, we build a risk profile. Signals are aggregated, relationships are considered, patterns are identified. And then ultimately that informs an action as an output. So for example, low signals coming out of the risk profile, then the claim is clean, or the claim can be considered to be clean and then straight through processing. Medium risk, targeted checks. High risk, flagged with context, not just an alert. So instead of saying this looks suspicious, we can say this looks suspicious, and here's the network of reasons why.
Okay, and that last part feels very important because the analyst isn't just starting from scratch. They're getting the context up front.
Correct. And we are not just surfacing alerts, right? We are surfacing explainable patterns. So the analyst can immediately see what triggered the concern, how it's linked to other entities, and why it matters, which dramatically reduces investigation time.
Okay, and in practice, what does this translate to? Because at the end of the day, businesses care about outcomes.
So in practice, we typically see significantly higher detection of coordinated fraud. Fewer false positives, become because context filters noise. Faster decisions and legitimate cases, and much more efficient use of the analyst time. So it's not just about catching more fraud. It's more about running a more intelligent operation overall.
All right, so this just isn't about adding more rules or adding a model. It's fundamentally a different way of structuring the problem and a different way of operating fraud detection as a system, which makes sense given that the problem itself has evolved.
Exactly. If fraud has become coordinated and system driven, then the detection has to follow suit.
All right, so if we had to zoom out a bit, we've gone from how fraud has evolved to why traditional systems struggle to a very different way of approaching detection. Where do you see this going? What does this look? What does the next few years look like?
Okay, I think the direction is fairly clear, right? Fraud is going to become more automated. No doubt about that. It's going to become more coordinated and increasingly assisted by AI, which means the gap between the attackers and the defenders will keep closing. And in some cases, the attackers, will actually move faster.
So are we heading towards like an AI versus AI situation?
Yeah, to some extent, yes, but I wouldn't overstate it. The real shift isn't, just AI versus AI. It's more of system versus system. The organizations that win, they won't necessarily have the best model. They'll have the best operating model around fraud.
What do you mean by that?
So it comes down to a few things. One of them being visibility. Can you actually see how things are connected across your business? Very important. And second to that is adaptability. Can your detection approach evolve, without this constant rework? Third one, it's going to be the signal quality. Are you surfacing meaningful patterns or just noise? And the last one being, are your analysts spending time where it matters? Most organizations, to be honest with you, most organizations already have this data. They already have tools. The question is whether, those pieces are working together or operating in isolation.
Okay, so if I'm sitting in a bank or insurance business today, what's the first thing I should be thinking about? Not in 5 years, but right now.
Okay, brilliant question. I would say start by asking, a very simple question. Are we looking at fraud at individual events or as a connected behavior? If it's still event-based, you'll catch some fraud. No doubt about that. But you will obviously miss the coordinated stuff. The second step, I would say, bring your signals together. Start linking entities and build visibility across the life cycle. You don't have to solve, everything at once, but you do need to start shifting, the way you think about the problem.
Okay, so it's less about adding more rules or plugging in more tools. And it's more about connecting what you already have and structuring it in a way that actually reflects reality.
Correct. Because fraudsters already think in systems, defense needs to catch up.
All right, I think that's a good place to land. If there's one key takeaway from today, it's probably this. Fraud hasn't just increased, it's changed its shape. And if we're still trying to detect it the way we did 5 or 10 years ago, we're going to struggle. Archie, thank you. That was quite insightful. And to everyone who's joined, thank you for your time. In the next episode, we'll continue to unpack how these agentic systems come across together across different use cases. Until then, take care.
Thanks, Kai.
You know, when you submit something online, maybe an insurance claim or some kind of application, have you ever stopped and wonder what actually happens in that split second after you hit the button? Well, today, we're going to pull back the curtain and show you the secret life of your claim, all in those first few moments right after you click. Okay, so let's set the scene. You've just uploaded your documents, you've filled out the whole form, and your cursor is sitting right on that submit button. You click it. For you, the job is done. But on the other side of the screen, a super complex, high-speed investigation has just kicked off, and the clock is already ticking. The second you submit, your claim doesn't just land in some digital inbox, waiting for a person to get to it. Nope. It's immediately handed over to what we're calling a digital detective. This is a really sophisticated, automated system that instantly opens a case file and starts hunting for clues, all without a single human getting involved. At least, not yet. And this detective is incredibly methodical. It follows this very precise 5-step process, and it does the whole thing in about a minute. First, you've got the event. That's you hitting submit. Then it jumps to signal evaluation, a digital twin query, it builds a risk profile, and finally, it takes final action. So let's walk through this case, step by step. Everything kicks off with the spark. This is the inciting incident, right? You've submitted the claim, you've attached your documents. The clock has officially started, and our digital detective now has its first piece of evidence, your submission. And there is zero time to waste. Our detective gets right into the investigation. The first order of business? Analyze the evidence that's right in front of it, the claim itself. It's doing this super fast scan, just looking for anything that might stand out, any initial little data points that might need a closer look. And this is where it starts to get pretty cool, because a clue could be just about anything. The system's asking questions like, was this claim filed at, say, 3 a.m? Is there anything unusual about the policy's history? Is the value of this claim way, way higher than what we'd normally expect? And all the while, it's checking this against a list of known red flags. These are the first pieces of the puzzle. You know, any good detective never works completely alone. So after gathering those first initial facts, our system turns to its most powerful resource, this huge network of information it calls the digital twin. So what on earth is a digital twin? Well, imagine a massive living map that connects every single piece of data the company has, like ever. It connects people to addresses, bank accounts to multiple policies, that one repair shop to dozens of past claims. Its whole purpose is to see this entire web of connections all at once, so it can spot these hidden relationships that a human analyst looking at just one file would probably never, ever find. And this is where you really see its power. The detective asks the twin these really specific questions. Hey, has this repair shop ever popped up in other sketchy-looking claims? Is this same bank account connected to 5 other policies, all under different names? It's digging for those non-obvious, indirect links that can tell a much, much bigger story. Okay, so our detective has its initial clues, and it has the deep intelligence from its network. Now it's time to pull it all together. This next phase is all about putting together the final case file, which the system calls the risk profile. And the really crucial thing here is that no single clue decides the whole case. The system basically acts like a funnel. It just pours in everything it's found, the timing, those weird relationships, the initial red flags, and it weighs them all together to get the full picture of this one claim. And the result of all that super complex analysis? Well, it gets boiled down to one single straightforward number, a risk score. This score instantly tells the system how confident it is about the claim, turning a whole mountain of data into a simple, actionable insight. And that score? It leads us directly to the climax of our story, the verdict. Based on where that number lands, the claim is immediately sent down one of 3 very different paths. And here it is, the action matrix that shows those 3 paths. If the risk score is low, great, the claim is approved automatically, no human has to touch it. That's straight through processing, and it's crazy efficient. If it's medium risk, it gets sent over to a person for some specific, targeted checks. And if it's high risk, it gets flagged with all the evidence for a full manual investigation. And for those high-risk cases, this is probably the most important part. The system doesn't just send up a blinking red light that says, "Problem." It delivers the entire case file, all the clues, the hidden connections, the reasoning, right to the human reviewer. See, the goal isn't just an alert, it's to give the full context so a smart human decision can be made. So, there you have it. In less time than it takes to make a cup of coffee, your claim has been submitted, investigated, and routed. This kind of efficiency is, well, it's incredible, but it also leaves us with a really critical question to think about. As these digital detectives get smarter and faster, how do we make absolutely sure we're building them to be not just efficient, but also fundamentally fair?
Archie, thank you so much. That was a really insightful discussion. If there's one thing to take away from today, I think it's this. Fraud hasn't just increased, it's changed shape. What used to be isolated incidents is now coordinated across customers, claims, and even channels. And that means the way we detect it has to evolve as well. The real advantage comes from building a connected view, combining signals, relationships, and behavior over time. That's how organizations detect fraud earlier, reduce false positives, and focus the efforts where it matters the most. So the message is simple. Fraud detection needs to become more connected, more adaptive, and more intelligent. If today's discussion resonated with you, feel free to reach out to us, connect with the team. We'll share some more information around the topic. And then looking into episode 5, we'll be exploring how AI is already reshaping insurance from underwriting to claims, assessor workflows, and QA auditing. Thanks so much again for joining us this episode. We'll see you next one. Cheers.